The general form of a quadratic equation is ax squared plus bx plus c equals 0, where a, b, and c represent constant values and x represents the variable. One approach to solving a quadratic equation is by factoring and using the zero product principle. The zero product principle says that if we have the product of factors that equals 0, then one of those factors has to equal 0. So if m times n equals 0, either m equals 0 or n equals 0. This allows us, in the situation of quadratic equations, to simplify a factored equation into two simpler equations. So let's take a look at the following example. I'd like to solve this equation using factoring and the zero product principle. In order to do so, I need the equation to be in the general form, where all non-zero terms are on one side and zeros on the other. So let's start by subtracting 4x from both sides, and also subtracting 32 from both sides of the equation. That gives us x squared minus 4x minus 32 equals 0. And now, to apply the zero product principle, we need to factor the left-hand side. To factor the trinomial, I want to look at the 32, negative 32, and try to find a factor pair that adds to equal negative 4. So, since I want a negative result, I want the bigger factor to be negative, so I could list some of the factors if I can't think of it right away. And it turns out that 4 and negative 8 will do the job, because 4 plus negative 8 is negative 4, and 4 times negative 8 is negative 32. So the trinomial factors as x plus 4 times x minus 8. And so we have those two factors on one side of the equation and 0 on the other. And again, what the zero product principle tells us is that I can take each of those factors and set them equal to 0 to create simpler equations. So either x plus 4 has to equal 0, or x minus 8 has to equal 0. Now for this first equation to be true, we need x to equal negative 4, and for the second equation, we need x to equal positive 8. And so that gives us two solutions to the quadratic equation. We can describe them by writing a solution set of negative 4 and 8. And I'm going to put that solution set in curly brackets, braces, to describe it as a list of numbers where the order doesn't matter, but it's just a list of the possible solutions to the equation. As a second example, let's take a look at the equation 10y squared plus 5y equals 0. In this case, we don't have a trinomial, but I do have some terms on the left-hand side and 0 on the other side, so I'd like to factor the left-hand side before trying to apply the principle of zero products. And you might notice there's a common factor. 5y is a common factor of those two terms, so I can factor it out. 5 divides into 10 two times, and because it's a y squared in that first term, factoring out one y leaves a y behind. For the second term, we just have 5y, as that entire term, so if we factor out 5y, I need to put a 1 behind as a placeholder. So if you think about going backwards, I could multiply this out. 5y times 2y gives us that 10y squared, and 5y times 1 gives us the additional plus 5y. But I want the factored form for what I want to do next, because the factored form now is equal to 0, and the zero product principle tells me that that means either 5y equals 0 or 2y plus 1 equals 0. Solving those simpler equations, dividing the first one both sides by 5, we end up with y equals 0, because 0 divided by any number, 0 on the top of a fraction, is always equal to 0. And on the other side, I can subtract 1 to get 2y equals negative 1, and then divide by 2 to get the solution y equals negative 1/2. So again, there are two possible solutions to this second equation. Either 0 could be a value for y, or negative 1/2. And we could double check by taking those two values and plugging them back into the original equation to see that it does in fact make the equation true. I hope you enjoyed the video. Thanks for watching.